Welcome to week 8 of quality quant questions. Hopefully the series is proving beneficial for you. If nothing else, this can serve as good point for revision of all the topics that you have done so far. Let's go through this week's questions. For this week especially, I will be doing different sorts of processings. Sometimes I'll use alligations, sometimes I'll use number fitting, sometimes I'll use ratios. Basically, I will be using different ways. Not to say that those are the best ways of solving those particular questions. It is just that those are the ways that strike me the fastest. Additionally, I am trying to showcase different ways of solving, and therefore different ways. I will not be sticking to one particular style only for solving. Let's get to individual questions. First one, a cylindrical container is having the top surface of a liquid at a level of 4/7 of its full level. From this, if X liters is removed, the container is 1/4 full. Okay. Container is 1/4 full. Finally, 35 liters is added to the container from this position, making it half full. So from 1/4, if we are going up till half, let's say this is visually this would, if 1/4 level is this and half level is this, how did we arrive from 1/4 to half position? By filling up 35 liters. So 35 liters is equal to half the container minus 1/4 the container, which is equal to 1/4 of container. Container size will therefore be 140 liters. Container size will therefore be 140 liters. Okay. Find the value of X. What was X? The container was 4/7 full. So it had 80 liters present. Container had 80 liters present. From this, something is removed to bring it to 1/4 level, to bring it to 35 liters. So how much was removed? 45 liters was removed. 45 liters was removed, and the container size was 140. Therefore, the answer to the question here has to be option C. Next, a container has 80 liters of milk. From this container, 8 liters of milk was taken out and replaced by water. This process was repeated once. How much milk is there in the container? This is the simplest version of replacement. Understand? Every time you have two entities present in the container, something is taken out, something is added, something is taken. First focus on which element you want to work on. Do you want to work on milk or do you want to work on water? Between the two, the preferred element to work on is the element that is changing predictably. Look at milk. Every time you take out 8 liters from the container, every time you take out 8 liters from the container, you are essentially taking out 10% of the container. But water, first time you're taking out 10% of water, second time you're adding 8 liters of water. Then you're taking out 10% of water, then you're adding 8 liters of water. Water is changing in percentage terms once and then in quantity terms. But milk, it is only changing when you're taking out stuff from the container. So the element to focus on here is milk. And with milk, what is happening? There were 80 liters of milk. Every time 8 liters was taken out, 90% of the milk stays back. So after the first iteration, this is the quantity of milk. After the second iteration, this is the quantity of milk. We have to figure this out. Cancel, 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 cancel. 9 into 9 is 81. 81 into 8 is 648. 648 by 10. Or our final answer here will be 64.8. Or option A will be the right answer. Next question. Product M is produced by mixing chemical X and Y in the ratio 5:4. Chemical X is prepared by mixing two raw materials A and B in the ratio of 1:3. Okay, see. Chemical X is a multiple of 4. If I want it to be represented in integer terms, it is a multiple of 4. It is also a multiple of 5. So I will update the ratio of X is to Y as 20:16. So that it is a multiple of 4. Breakage into A and B is easier to handle. Then chemical Y is prepared by mixing raw materials B and C in the ratio of 2:1. So Y can be broken down into 3 parts, and it is also a multiple of 16. So right now what I'm doing is M is composed of 2 parts, which is X and Y, and I will update this ratio to 60:48. So that 60 of X is there, 48 of Y is there. Now X will break down into 1:3 ratio of A will be 15, B will be 45, and Y, this breaks down into B and C. B will be 32 and C will be 16. So for M, if I simply want to break it down into A, B, C, A will be 15, B will be 77, and C will be 16. And at this time, M will have 108 units. Out of 108 units, A is 15, C is 16, B is 77. Okay. Then the final mixture is prepared by mixing 864 units of M with water. If I want to take M to 864 units, I need to multiply every number by 8. So M will be 864 units. A will be 120 units now. C will be 128 units. And B will be 77 into 8. So 640 minus 26, 616. 616 units. B will be 616 units. 560 plus 56, yes, everything is fine. If the concentration of raw material B in the final mixture is 50%. So 616 is 50% of the total mixture. So this M, we were mixing some water, which means 616 divided by 864 plus whatever quantity of water we added is equal to 1 by 2. How much water was added? We simply need to figure out the value of this W. 616 is 1232 equal to 864 plus W, or W is equal to 368, or option B will be the right answer for this question. Okay, this is where I am doing number fitting instead of getting into alligations and all sorts of wonderful things. Next, a beaker contains milk and water in the ratio 5:3. If a person removes 6 liters of this mixture and replaces it with pure water, pay attention, we are removing the mixture and replacing it with pure water. So between milk and water, milk is the preferred element to work with. The ratio of milk to water becomes 1:1. What is the amount of milk present in the beaker initially? Okay. Let's say initial quantity that was present with us was 8x. So now the quantity of milk present with us will be 5 by 8 of 8x minus 6. This is the quantity of milk present. And this divided by the total volume. We take out 6 liters and we replace it with water. So the total volume remains 8x. This is equal to 1 by 2. If milk to water is 1:1, milk is half of the solution. This is the working we have. So from here, this becomes 4x, 32x. 32x is equal to 40x minus 30. 32x is equal to 40x minus 30, or 8x is equal to 30. And I don't need to figure out the value of x, because what I needed was 8x only. I now have the total volume of the initial mixture. Total volume of the initial mixture is 30. What is the amount of milk present in the mixture initially? The milk present will be 5 by 8 into 30, which will be 150 by 8, which will be 18.75 liters, or option A here will be the right answer. Next, 2 identical vessels are filled with alcohol. From the first vessel, 8 liters of solution is taken out and replaced with 8 liters of water. From the resulting mixture, 8 liters of mixture is removed and again replaced with 8 liters of water. Okay. The same operation is done in second vessel, and the same number of times. So 2 times, same operations is done in vessel 2, but the amount of solution removed and replaced with water is 2 liters. What fraction of the volume of the vessels is A if the strength of alcohols in the 2 vessels finally is in the ratio 25:60? Now see, the volume of both the vessels, wherever they are, from the point that they're starting to the point that they're ending, is the same. The volume of the vessel, the volume of alcohol in both the vessels at the beginning was identical. The volume of and eventually also the volume of both the vessels remains identical. So what is happening? First time from X we remove A, we replace it with water. Second time also from X we remove A liters. In the second instance, from yes, from X, where X is the volume of the vessel, we remove 2A. And in the second instance also, from X we remove 2A. And this has been given to us as a very fine number, 25 by 16. Can you see? I have perfect square in the numerator, perfect square in the denominator. In both these iterations, the volume of milk that was present, previously 100% was sorry, milk I'm saying. Previously 100% of alcohol was there. First time it reduces to X minus A. Whatever the multiplicative impact was, it gets repeated the second time. Similarly, for the second one, 100% was alcohol. Whatever the multiplicative impact was of taking out minus 2A, it repeated in the second instance also. So, we get this equation. This will transform to X minus A by X minus 2A is equal to 5 by 4. So, we get 4X minus 4A is equal to 5X minus 10A, or X is equal to 6A. Finally, what did we need? What fraction of volume of the vessels is A? So A is equal to 1 by 6 of X. Therefore, the answer to this question will be option D. Okay, next. Some amount of acid is taken out of a 54-liter vessel full of acid, and then an equal amount of water is added. This process is repeated once more. As a result, the vessel now contains 24-liter pure acid. Okay, you can see 54 minus X to 54 minus X into 54 minus X into 54 minus X is leading me to 24 by 54. Okay, not 100. It should not be 100. Should I write it this way? No. Using the same framework, I had some quantity of acid, 54 minus X is taken out. So this is the quantity of, let's say, 54 into 54 minus X into 54 minus X. This is the quantity of acid left. This is turning out to be equal to 24. Okay. This is turning out to be 24. 54 minus X whole square is equal to 4 by 9. This is problematic, no? Because right now I'm taking 54 and taking out some value. How am I getting a fraction? So I must have made a mistake in formulation. Let me correct it. Think again. See, I can see the answer. I can see the answer. The answer is clearly something, but how do I explain it in terms to somebody who is not familiar or conversant with the area? That is turning out to be a challenge. Anyway, some amount of acid is taken out of 54. So what will be the percentage impact? Say, let's say 54 to 100 minus X by 100 into 100 minus X by 100 is equal to 24. the percentage impact of taking out whatever quantity we are taking out, percentage impact. Okay. So this gives me 100 minus x by 100 whole square is equal to 4 by 9. 100 minus x by 100 is equal to 2 by 3. Or from this, we can potentially get to x is equal to 33.33%. Every time you are taking out something from the vessel, you're taking out 33.33 liters, 33.33% of the vessel. If you're taking out 33.33% of the vessel, and the vessel was 54 liters, the answer to the question will be 18 liters. Or you could also have framed it this way: 54 minus x into 54 minus x divided by 54 should be equal to 24 by 54. 54 goes away. 54 goes away. This is not a good maths formulation. This percentage working is better. At least that is what is striking me right now. Maybe on some other day, when I'm in a different state of mind, I get to it. The answer is clearly 18 liters. From 54 liters, you take out 18 liters, you take away 1/3. Then you take away 1/3 again. 54 into r square leads me to 54. R square is equal to 4 by 9, or r is equal to 2 by 3. Every time you take away something from the container, you're leaving behind 2 by 3. So you're taking away 1 by 3. So 1 by 3 of the vessel is 18 liters. That is the best working that I can think of right now. Okay. Next, 2 jars contain milk and water in the ratio 5:4 and 2:1 respectively. What volume should be taken out from the first jar and second jar to fill up a third 30-liter jar with milk to water in the ratio 1:1? Now this is directly the answer of impossible situation. See here, milk is greater than 50%. Here, milk is greater than 50%. If I mix these two, the average presence of milk will necessarily be greater than 50%. But eventually, the proportion they want is 50% milk only. That is never going to happen. And therefore, the answer to the question has to be option D, impossible situation. Next, 3 milkmen, Ramu, Kamu, and Namu had 5 liters, 10 liters, and 15 liters of milk water solution respectively. In the solution that Kamu and Namu had, when you have names, pay attention to the order of the names. These are the last two names. The ratio of milk and water was 2:3 and 1:4, which means milk and water 2:3. So 4 and 6 and 1:4. Milk is 3, water is 12. All of them sat together and mixed their respective solutions together. Okay. They sold the combined mixture for rupees 20 per liter, and Ramu got 2.5 liters for every liter of mixture. Which means Ramu got 1/8. Ramu got 1/8 of the total revenue on. What was the milk water ratio in the solution that Ramu had with him? Assume that water comes free of cost and they share the revenue in the ratio of milk content. Okay, so Ramu had 1/8 the milk. So Kamu and Namu should have 7/8 the milk. In our current working, Kamu and Namu have 7 liters. If that is equal to 7/8, the milk and water split for Ramu will be 1 and 4. He will have 1 liter of milk. 1 plus 4 plus 3 is 8. He gets 1/8. So the answer to the question has to be option A. Next, in what proportion can 3 varieties of sugars priced at 10 kg, 12 kg, and 18 per kg be mixed so that the price of the mixture is 14 per kg? Now see, for this question, a useful tool is assumed mean working. Look at this. Here we have -4. -4 from 14, I'm taking assumed mean deviation, -4. Here I have -2, and here I have +4. Basically, whatever ratio numbers are given, We multiply them with the deviation, and if the eventual sum is 0, that is an acceptable ratio. If the eventual sum is not 0, it is not an acceptable ratio. Minus 2 into 4 gives me minus 8. Minus 2 into 2 gives me minus 4. 5 into 4 gives me 20. The summation is not 0, does not. Minus 8, minus 6, 16 does not give me the average price is 14. Minus 4, minus 6, 16 does not give me average price as 14. Minus 12, minus 8, plus 20. Yes, the deviation here is 0. Just see, 3 liters of 10 and 4 liters of 12, 48, and 5 liters of 80, 90. This is the cost. And 3, 4, 5, 12. This adds up to 168. This is the cost in individual terms. And overall cost, if I find out, 14 into 12, that is also equal to 168. So the answer to this question has to be option D. Next, pipe X pours a mixture of acid and water. Pipe Y pours pure water into a bucket. So I'm saying X has acid and water. Let it be A, let it be B. And Y only has water. Okay, let it be C. After 1 hour, the bucket got filled and the concentration of acid in the bucket was noted to be 8%. Concentration was noted to be 8%. So A divided by A plus B plus C is equal to 8 by 100. After an hour, this is the situation. See, A, B, C, these are the amounts of acid, water, and water they send in 1 hour. If pipe Y was closed after 30 minutes and pipe X continued to pour the mixture, concentration of acid in the bucket after 1 hour would have been 10%. Now see, in the other storyline, X is working normally. Acid only comes from A plus B. But because Y was closed after half an hour, it will only send C by 2. This is told to us as 10 by 100, 10%. Finally, what is the ratio of acid to water in the mixture? We want A is to B fine. Okay, let's work our magic. First thing we get 100A is equal to 8A plus 8B plus 8C. Here we get 100A is equal to 10A plus 10B plus 5C. 100A is equal to 10A plus 10B plus 5C. Now we can equate this 8A, or we don't have to equate this. Remember, finally I need the ratio of A's to B. So I want to get rid of C's. So I multiply this by 5. I get 500A is equal to 40A plus 40B plus 40C. I multiply this by 8. I get 800A is equal to 80A plus 80B plus 40C. Now I can get rid of C's entirely. So I get 300A equal to 40A plus 40B. This comes over here. 260A is equal to 40B, or A by B will be equal to 2 by 13. This is the final ratio we wanted. So the answer to the question will be option D. Okay. Beaker A and beaker B contain methanol, ethanol, and phenyl in the ratio 1:3:2 and 2:1:5 respectively. Some parts of the solutions from beaker A and beaker B are thoroughly mixed and put into another beaker C. Which of the following cannot be the ratio of methanol, phenyl, and ethanol in beaker C? As previously stated, pay attention to the order of the elements. The order here is methanol, ethanol, phenyl, but in the final ratio that they're asking, it is methanol, phenyl, and ethanol. So trickery is already involved. Because the final ratio is this, I will write it down that way. Methanol, phenyl, and ethanol. Should mean the first mixture, beaker A has 1:2:3. The second one has 2:5:1. Beaker B has this. Now, which of the following cannot be the ratio of methanol, phenyl, and ethanol in beakers? Cannot be the ratio. Okay. The most important thing to note here is, if I'm looking to generate any of these ratios, the best thing I can do is I will multiply. See, I will multiply this ratio by something and this ratio by something, some liters of A and some liters of B. If I can create this ratio, that is eliminated as the answer. Let's see, for the first one, I see that for the first one, E for ethanol, this is a multiple of 3. This is also a multiple of 3. Okay. So if I get this to, oh, this is also a multiple of 3. So this should be a multiple of 3. B should be a multiple of 3. If I take 3 times or 3 into 8, 24 liters of B. If I take 24 liters of B, basically I'm multiplying this entire ratio, every term with 3. I will have 3 from here. I'll need 4 from here. Now see, am I getting that ratio? 1 into 4 is 4, 2 into 3 is 6. So yes, 10 is generated. 2 into 4 is 8, 5 into 3 is 15. Yes, 23 is generated. And 3 into 4 and 1 into 3, 15 is generated. So if I take 24 liters of A and 24 liters of B, my work can be done. This ratio can be obtained. Because this ratio can be obtained, this is not the answer. Okay, let us check the next option then. 7, 15, 16. Now in this checking, always look at, I have 15 here, I have a multiple of 5 here. Great. So this has to be a multiple of 5. I multiply this by 5, I get 10. Let's multiply this by 1 and see if it works out. 1 into 5 and 2 into 1. I am getting a 7. 2 into 5 plus 5, I am getting a 15. 3 into 5 is 15 plus 1, I am getting a 16. Which means if I take 30 liters of A and 8 liters of B, option B can be generated. The ratio can be 7:15:16. So this cannot be the answer. Next case to check is 6:13:30. 6:13:30. Here 13 and 13 are not that great, so I'll have to work with 6. Let us look at 2. I have 2 here. So this has to be the ethanol in A has to be a multiple of 2. Let me multiply this by 2. If I get this as 2, I will get this as 2 as well. In order to reach 6, I will need this into 2 gives me 2. I need 2 into 2. So see, I get 6 from here. 5 into 2 plus 2 into 2. Ooh, this is not working out. Look at this. 5 into 2 is 10 and 2 into 2 is 14. I'm not getting a 30. This is not acceptable. So this working is not fine. The next case I can check is, let me take this as 4 now. The next even number. If I take this as 4, this has to be 1. Let's see if it works out then. 1 into 4 plus 2 into 1. Yes, 6 I'm getting. 2 into 4 is 8. 5 into 1 is 13. Yes, I'm also getting 13. 3 into 4 is 12. 1 into 1 is 13. I'm also getting 13. So this cannot be the answer. I have ruled out option A. I've ruled out option B. I've ruled out option C. By default, the answer has to be D. And for D also, let's see if some working can be done in order to arrive at this. I have 9, 20, and 18. I could work with 20, I could work with 18. Let's work with 20 first. This is a multiple of 5. So this has to be a multiple of 5. This has to be a multiple of 5. If I multiply this by 5, this would need to be multiplied by 2 in order to arrive at 20. But then what would happen? 1 into 5 plus 2 into 2. I would get 9 is to 20 is to 70. But the ratio is supposed to be 9 is to 20 is to 18. Not happening. Working with P is not useful. The next case, if I had to take, you see the next case is not possible at all, because as soon as I do 2 into 5, I did. That did not work. The next multiple of 5 is 10. If I did 2 into 10, I would already reach 20. This 5 will become additional and useless. That is not needed. So I can't do that. Let's say we started off working with ethanol. Ethanol was the element we were working. This is a multiple of 3, so this should be a multiple of 3. So this is 3. This should be multiplied by 5. This time I get 5 plus 6. For methanol in A, it will be 5. In B, it will be 6. It is 11. Not great. We can't have this. So next case would be, let this be 6. This is 6. This will have to be 3. Now see, 1 into 3. Great. And 2 into 6 is 2 into 6 is giving me 12. 1 into 3 is giving me 15. But I only need a 9. Not great. Any case that I generate, let me put down 9 into 2. I'm already exceeding this 9. I'm already exceeding this 9. The only way it could have gone down is if I put down 3 here and something here. But 3 here and 3 here. 3 here and 3 here. This will perhaps give me 12 in ethanol and 21 in phenyl. There is no way 9 is to 20 is to 18 can be generated. The answer to this question has to be option D. The processing is very simple, yet it is not very intuitive. Processing is not very intuitive. You have to sort of work this out. One additional insight that I want to put. See, there are certain questions in which you have to check options. As for instance, this one. Notice that in most cases, not all, but in most cases, questions in which you have to check options, invariably the answer is among the last few options. Because even the question setters realize that people check options in order. So those who end up spending more time in the initial option checking will flounder. Not just this example. There was this example as well. Can you see? This is where we were checking options. The answer was option D. So my advice to all the students is when you attempt questions in which options are to be checked, Quant or in DILR for that matter, please always start with the last option. It is not that there are going to be questions in which the first option is correct. There are going to be questions in which the second option is correct. But in greater than 70% of the questions, you will see that usually option 4 or option 3 is the answer, in which case you will save some precious few seconds. Okay, next question now. There are 2 alloys of copper and aluminium in the ratio 7:2 and 7:11 respectively. If equal quantities of the 2 alloys are melted to form a third alloy, then find the ratio of the copper to aluminium in the newly formed alloy. This altogether is 9 units. This altogether is 18 units. So let me take double of this. 14:4. So I have 14 and 7. 21:15. Ratio of copper and aluminium. Paying attention, the question is still asking copper and aluminium. So the final ratio will be 7:5. Simple one. Next, there is an alloy A of silver and copper. A certain weight of this alloy is mixed with 15 kg of pure silver and melted. The new alloy B contains 90% of silver. If the alloy A is mixed with 10 kg of 90% silver alloy, the new alloy C is found to contain 84% silver. Find the percentage of silver in alloy A. Okay. Now, this is where I mean alligation is a way we know. If you try to impose alligation upon the setup, it is going to be very, very difficult. But if I say, let's say alloy A, I have silver, I have copper. I put this down as X, I put this down as Y. I don't know why I have extra P here, but copper, X and Y. A certain weight of this alloy is mixed with 15 kg of pure silver. So X plus 15 divided by X plus Y plus 15 is equal to 90% silver we had. We get 9 by 10. This is the first working. This is the first working. In the second case, if this alloy A is mixed with 10 kg of 90% silver alloy, which means out of 10 kg, 9 kg was silver. X plus 9 by X plus Y plus 10. The total alloy, 10 kg was total alloy that was being added. Out of that, 9 kg was silver. The new alloy C is found to contain 84% silver. So we get 21 by 25. Yo, we have two equations, we have two variables, we can very easily solve. Let's go ahead, solve. 10x plus 150 is equal to 9x plus 9y plus 135, or x is equal to 9y minus 15. Replace this in the second one. 9y minus 6 or 10y minus 5 is equal to 21 by 25. Or I can cancel the 3's from the top. 3y minus 2 is equal to 7. I can cancel off the 5's. 2y minus 1 is equal to 5. Simply simpler. 15y minus 10 is equal to 14y minus 7, or y is equal to 3. Okay. Y is equal to 3. Then this was not the objective. Objective was to find out percentage of silver in alloy A. Y is 3, X will be equal to 12. Now, what is the percentage of silver in alloy A? It is 12 by 15. This is equivalent to 80%, or option A will be the right answer. Okay. Next, two alloys of iron have different percentages of iron in them. The first of them weighs 6 kg and the second one weighs 12 kg. One piece each of equal weight was cut off from both the alloys. The piece from the first was mixed with the leftover part of the second alloy, and the piece from the second with the leftover part of the first alloy. As a result, the percentage of iron became the same in both the alloys. What was the weight of each cut out pieces? Now, if you haven't come across this question in your mixture alligation working classes, sheets, exercises, whatever you are going through, if you haven't come across this question or a version of this, then your material is lacking. This is like a test of your material, because this is a very, very standard question. In fact, if I'm not mistaken, back in 2021, this question, a version of this was asked in SNAP, was also asked in CAT, was also asked in XAT. The same year, the same question, different versions was asked. Now, you can solve it algebraically, and there are multiple ways of solving this algebraically. There is a direct formula also that people have broken it down into. I am not a formula person because I have very weak memory. What I have broken it down into for my working is, look at the ratio of the weights. I have 6 and 12. The ratio is 1:2. Break this down into 1:2 ratio. I will have 2 kg and 4 kg. And break this down into 4 kg and 8 kg. This is from A, this is from B, alloy A, alloy B. Now, you can happily exchange these 4 kgs. I have 2 kg A and 4 kg B. Whatever purity of iron I get is going to be same when I have 4 kg A and 8 kg B. Basically, whatever is the ratio of the total weights, break down the individual weights in the same ratio. Whatever is the common number, that is the number that gets exchanged. The answer to this question is, of course, option A. Okay. Next, after the addition of 35 liters of water to a can of diluted milk, the concentration of milk in the can becomes 30%. Okay. So let's say in the can, we had milk, we had water, milk and water. So milk by milk plus water plus 35 is equal to 3 by 10. Now further 40 liters of water is added to the can. The concentration of milk in the can gets reduced by 10 percentage points. Hopefully, we know 10 percentage points. Previously, it was 30%, now it will be 20%. 40 liters is added. So, milk, right? Milk plus W plus 75 will be equal to 2 by 10. Okay. How many more liters of water must be added to the can now such that the concentration of milk in the can becomes 8%? We'll worry about it later. We have two equations, two variables. We can very much solve it. Here we get 10m is equal to 3m 3w plus 105. From here we get 10m is equal to 2m 2w plus 150. I want to get rid of w's. Want to get rid of w, so I'll multiply this entire thing by 2, this entire thing by, in fact, I'll simplify this further. 7m is equal to 3w plus 105. This will translate to 8m equal to 2w plus 150. I'll multiply this entire equation by 2, this entire equation by 3. Get 14m is equal to 6w plus 210. Second equation will be 24m is equal to 6w plus 450, or m 10m will be equal to 40, or m is equal to 24. So the can originally had 24. Now if the can originally had 24, 24 reduced to 3. 24 reduced to 3. So this entire thing should be 80. This entire thing should be 80. Okay. Or if the can had 24, this is 24. This entire thing should be 120. Now to 24, the milk remains the same. To 120 that was present, we're adding some more water such that the ratio becomes 8 by 100. Cancel, cancel. 3 or 300 is equal to 120 plus W, or W is equal to 180. We need to add 180 liters of water to reduce the concentration of milk in the can to 8%. Okay. Next, in a mixture of 105 liters, the ratio of milk and water is 8:7. Okay, 8:7. So 15 units. So this is 56 liters of milk and 49 liters of water. Some amount of mixture is removed, in which 14 liters water. Now see, when you're removing something from the container, the ratio in which milk and water are removed is going to be 8:7. If 14 liters of water was removed, 16 liters of milk will be removed. So what are we left with? 40 liters of milk and 35 liters of milk. No, sorry, 40 liters of milk and 35 liters of water. And 5 liters of water is added afterwards into the remaining mixture. 5 water comes in. So now milk and water are 40 and 40. Then the ratio of the milk to water is 1:1. So this is option C. Next, two varieties of tea costing 280 per kg and 180 per kg are mixed in a certain ratio to form varieties T and Q. T and Q are mixed in the ratio 1:2 to form variety R, which is sold at 288 per kg at 20% profit. If P costs 200 per kg, in what ratio were the two varieties mixed to form Q? Let's see. We have to work our way back. First, let's look at variety. When it was sold at 288, you are getting 20% profit. So Cp of R into 6 by 5 is equal to 288. Cancel, cancel. I get 48. Or R average price turns out to be 240. Now, R is the average price of 240 when P at 200, P costs 200, and Q at some price were mixed in the ratio 1:2. You see, the gap here is 40. 40 is a gap of 2 units. So 20 will be a gap of 1 unit. So price for Q will be 20 more than 240, or it will be 260. Price for Q is 260. Now, how was this 260 obtained? How was this 260 obtained? By mixing two T's with respective prices of 180 and 280. 180, 280. The gap here is 80. The gap here is 20. The ratio here is to 4. In what ratio were they mixed? They were mixed in the ratio 1:4. Okay. Given that I don't have 1:4 available anywhere, I'll mark 4:1. Additionally, the question was saying 280 and 180, but I've solved it as 180 and 280. So maybe that is also a concern. Regardless, the answer will of course be option C, 4:1. Next, two vessels contain alcohol and water in the ratio 3:4 and 65:79. In what ratio should the solution in the first vessel be mixed with the solution in the second so as to get a solution with alcohol and water in the ratio 4:5? Okay. This is again allegations based solving, but this time what you have to take care of is look at alcohol alone. I have 3/7 alcohol and I have 65/144 alcohol, and finally I'm reaching 4/9 alcohol. Working with fractions is not convenient. Working with fractions is not convenient. So what should we do? What we should do is simply find out the LCM of each of these denominators. 9 and 7 is 63. 63 into 16 will be how much? 63 into 16 is going to be the LCM. But I don't really care for that LCM so much as if the LCM is 16 into 63 or 16 into 9 into 7, if this is going to be the LCM, can you see the numerator here has to be multiplied by 16 into 9? Numerator here has to be multiplied by 144. 144 into 3 is going to be 420 plus 12. So 432. 65 has to be multiplied by 7. 60 into 7 is 420 and 35. So 455. And this 9 has to be multiplied by 100. Sorry, this 4 has to be multiplied by 112. 112 into 4 is 448. And now our working will be very easy. The difference here, 16. The difference here, 7. So in what ratio have they been mixed? They have been mixed in the ratio 7:16. And our work is this easy. Just that convert the fractional numbers into integers by simply taking away the power of the denominator. Okay. When I say power, I mean the influence of the denominator, not index, the influence of the denominator. Okay. Next question. Vessels A and B contain mixtures of milk and water. The ratio of milk and water in A and B is 4:5 and 3:1 respectively. In what ratio should the containers of A and B be drawn and mixed to obtain a mixture having milk and water in the ratio 3:2? Okay. Milk here was 4/9. Milk here was 3/4. Finally, we want milk as 3/5. This is again simple. 180 will be the LCM. And 9 into 20. So this will become 80. This will be 45 into 3. So this will turn to 35. It will be 36 into 3. So 0.8. This is 27. This is 28. In what ratio should they be mixed? It will be option A. It is pretty much a exercise on stuff we learned in the previous page. Simply turn the ratio numbers or the fractional shares into integers, and then the allegation based working is easier to accomplish. Final question. There are two containers having mixtures of hydrochloric acid and water. In container 1, the ratio of hydrochloric acid and water is 1:2. And in container 2, the ratio of hydrochloric acid and water is 4:1. Find the amount of mixture that should be taken from container 1 in order to make 28 liters of mixture containing equal amount of water and hydrochloric acid. Okay. Let's see. You can do it equation wise, wherein you have hydrochloric acid, 2, 6, 4 and 1. We need 28 liters. 28 liters. So altogether, I can try to fit in. This is from vessel 1, this is from vessel 2. I can try to fit in numbers, integral numbers, and see if the case can be made. Finally, I need 14 here and 14 here. If this is also 14, this is also 14. Both of these have to be multiplied by even numbers. First, I put down 6 here. If I put down 6 here, this will be 14 into 6, and this will be 8 into 6, 8 into 1, 6 into 4. Not great. 8 into 2 and 6 into 1 is great, but not great enough. We can solve it this way, one way that we had studied earlier, but that is not really the ideal way here, or at least that is not what is striking in my head. In my head, what is striking is, the first one, we had hydrochloric acid as 1 by 3. The second one, we had hydrochloric acid as 4 by 5. And finally, we need hydrochloric acid as 1 by 2. This is it. This is the simple thing. So 5, 3, 2, 30, 30 we are working with. So 10 and 24 and 15. The gap here is 5. The gap here is 9. So the ratio in which container 1 and container 2 should be mixed is 9:5. Now we know we get eventually 28 liters in total. We get 28 liters in total. This is only 14 units. In order to get to 28 liters, multiplied by 2, this becomes 18. This becomes 10. So 18 liters from vessel 1 and 10 liters from vessel 2. Finally, the question was, find the amount of mixture that should be taken from container. So answer will be 18 liters. And that is the entirety of this sheet. Hopefully you learned something, some new styles, some new ways of processing. If you learned something, great. If not, please continue practicing. That would be all.